Hello students and welcome to the Automobile Engine class. Myself Shankho Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandrasur Degree Engineering College under the JIS group. So students, in the few of the last classes we started here to discuss about the sixth module, and the topic is engine performance and testing. So here in these subjects we already covered the three parts. In the first part, we discussed about the various types of engine parameters, engine power, and the engine efficiency, which is play an important role when we are this talking about the engine performance or the calculation parts. Then on the second part, we discuss about the air fuel ratio and Morse test, motorized test, and the study about the dynamometer and its principle. Then on the third part, we continue this dynamometer with the various classifications of its. Then we discuss about the heat balancing, and then we study about the performance characteristics curves. So now from today in this class we started the numerical about this engine performance and the testing. So students, here let's start the first numerical for the sixth module, and which is the uh, engine performance and testing. The numerical is a there is a six cylinder. There is a six cylinder. The gasoline engine operates on four-stroke cycle. The bore of each cylinder, that is the 80 millimeter, and stroke is 100 millimeter. Bore is 80 millimeter and stroke is 80 millimeter. The clearance volume per cylinder is clearance volume per cylinder is 70 cc or 70 cubic centimeter. 70 cc, 70 cubic centimeter. Speed is 4000 rpm. The fuel consumption is 20 kg per hour. The fuel consumption is 20 kg per hour. The torque which is developed is 150 Newton meter. So here we need to calculate the brake power, brake mean effective pressure, brake thermal efficiency. When the calorific value is 43,000 kilojoule per kg. The relative efficiency of a brake power, which is basis assuming the engine work on a constant volume cycle where gamma is 1.4 of the air. So you have the air. So from this question we need to from the equation, from this numerical, we got that the given thing is that the number of cylinder is 6. It's a SI engine, 4-stroke SI engine. The bore is 80 millimeter, stroke is 100 millimeter, clearance volume is 70 cc, speed is 4000 rpm, fuel consumption is 20 kg per hour, and the torque is 150 newton. So these are already given here, and from there now we need to find out calculate the brake power, brake mean effective pressure, brake thermal efficiency when the calorific value is 43,000 per kilojoule per kg, and we need to also find out the relative efficiency at a constant volume cycle when the gamma is 1.4 for the air. So this is the numerical. So we need to solve it. So students, first of all we note down here the given data. Note down the given data. Given data means number of cylinder is 6. Number of cylinder is 6. Bore equals to bore diameter is 80 millimeter. Stroke length equals to 100 millimeter. Clearance volume equals to 70 cc or cubic centimeter. Speed equals to 4000 rpm. Fuel consumption equals to 20 kg 20 kg per hour. Torque equals to 150 Newton meter. So these are the that are given, and we need to find brake power, brake mean effective pressure, brake mean effective pressure, pressure, brake thermal efficiency, and the relative velocity. Relative efficiency. For the calculation of these things, brake power, brake mean effective pressure, brake thermal efficiency, and relative efficiency. There are also 2 points are given. Those are the calorific value of fuel equals to 43,000 kilojoule per kg, and the value of gamma equals to 1.4. These are the given and these are need to be find out. So students, let's start the solution of this problem. Now solution the first one, brake power. So we knew the equation of the brake power. We know the equation of the brake power is equals to power is equal equation is equals to 2 pi n t divided by 60 into 1000. Now here we put the value. I put the value in here. So for the n, the value of n, that is 4000 into 4000, which is already given in the problem, and the torque, which is also given in the problem, that is a 150. From here we got the value of this 2 pi 2 into pi into 4000 into 150 divided by 60 into 1000 equals to 62.83 kilowatt. So this is the solution of the first part. Now coming to the second one, for the solution 2, we will find out the brake mean effective pressure. So we knew the equation of the brake mean effective pressure. We find out the, now we need to know calculate the mean effective pressure, and the equation is of the brake mean effective pressure is equals to the now I put here the upper portion, we put the BP, the value of the brake power, into 60 into 1000 divided by L into A into N into K. So now students, here just put the value here in this equation. The value of the brake power is 62.83, which is already calculated and find out from the above equation. Then now put the value of L. So we know the value of length L, that is 100 millimeter. Now it put in here in meter, so that's why it equals to 0.1 meter. Then area, that means pi by 4 equals to pi by 4 pi by 4 into d square. Here d means for d square, d means 80 millimeter. Now it convert into the then it find that it is 0.08 into square. N, value of n is equals to n by 2, as this is the 4-stroke cylinder which already told us. 4 by 2 means capital N by 2. Capital N by n means capital N means the 4000. So 4000 divided by 2, and then put the value of k. So here the value of k is means the number of cylinders. So here is the 6 numbers of cylinders are used. So the value of this equation, that is, when you calculate it, 62.83 into 60 into 1000, which is divided by 0.1 into pi by 4 into 0.08 square into 4000 by 2 into 6, and the value is 6.2 into 6.25 into 10 to the power 5, and the unit is Pascal. Now it is converted into the bar. So then we find that the value of the brake mean effective pressure, that is value is 6.25 bar. So this is the solution of the second answer. Now coming here to solve the third solution of find a third problem, where do we find that the brake thermal efficiency. So we know the equation of the brake thermal efficiency. We know that brake thermal efficiency equals to brake power equals to brake power divided by mass flow rate of the fuel, mass flow rate of the fuel into calorific value of the fuel. So now put here the value of this, put the value here, then the brake power, brake power is 62.83, mass flow rate, which is already given here, that is 20 kg per hour, means the fuel consumption is 20 kg per hour, but here we converted into this 20 kg per hour to the 20 kg per second. So that's why here with the brake power you multiply the 3600. So now the mass of flow rate you converted into the kg of per second, and now put the value of the CV. The CV value of the CV is 43,000 kilojoule per kg, and the and now we calculate this 62.83 into 3600 divided by 20 into 43000 53,000, and the value is 0.26, 0.26, and this is equal 0.263. Now this is equal to 26.3%. So this is the answer of the third problem. Now from here from here the brake power is solved, brake mean effective pressure is also solved, and the brake thermal efficiency will be also solved. This relative efficiency has just raised. So now let goes to the solution for the solution for for relative efficiency. Before when we go for to find out the relative efficiency, we know the equation of the relative efficiency, that is efficiency of relative efficiency, actual thermal efficiency, and the air standard thermal efficiency. Here we already find out the brake thermal efficiency, but we need to find out the air standard efficiency. As we know the equation of the air, need to find out the air standard CNC equals to efficiency of auto, as is a diesel cycle, equals to 1 minus 1 by R, 1 by R to the power gamma. Here R means compression ratio and gamma value is already given. So we know the compression ratio R equals to the equation, we know the equation of the compression ratio R is equals to R is equals to swept volume plus clearance volume divided by clearance volume. But here already the clearance volume is given, but we don't know about the swept volume, so need to find out the need to calculate the value of the swept volume. So the equations. So students, we know the equation of the Swift volume, that is A into L. Here A means pi. Here A means pi by 4 into d square, pi by 4 into d square into L. Now put the value here. The d means the board diameter of the board. So here the diameter of the board is given, that is 8, and L is given, that is 100. So from here we got the value, that is pi by 4 into d square into L, that is 0.14, and then we got the equation, that is 0.568. From there, now this value is put into this equation. So here the thermal efficiency is already calculated, 26.3%, that means 0.263 divided by here in this equation, that is 0.568, and this is equals to 0.263 divided by 0.568 is equals to 0.463, which is equals to 46.3%. So these are the answer of the this is the value of the relative efficiency. So students, here from this equation we covered these four find out things. The brake power, first of all we find out the solve the brake power, then we solve the brake mean effective pressure, then we solve the brake thermal efficiency, and after that at least we find this solution of the relative efficiency. So students, now here we completed one, we're doing one problem and its solution. In the next class we again do another problem. So still then, stay at home and stay safe. Thank you so much students.